Ladies and gentlemen, we're starting chapter 8 right now. Chapter 8 is about haloalkanes. And the first part of today, don't write anything down. We'll go back over here. This is one of the handouts I gave you. This is a handout you were given on the test. Okay? You ignored it already when you were studying for this last test, right? Because you saw it on the test 3 that you had to study. This is the part you're supposed to ignore. You can't ignore it now. What is this table good for? You don't have to write anything down. This is not an activity yet, okay? Well, it's good for figuring out the answers to these questions. They're not activity questions. Here's the question. How much energy is required? That's endothermic. Or made, that's exothermic, for each of the following reactions. Here it is. Here's one. Here is one. And do you remember what these hooks mean? One electron is moving. And what are these species called with unpaired electrons? They have a name. Radicals. Okay. This is called the BDE. What does BDE stand for? It's on this page. Bond dissociation energy. Are you surprised that you have to put in 402 calories? Answer. Plus that's not calories, 402 kilojoules per mole. The units are kilojoules per mole. I should read more carefully. 1, why is it endothermic? You have to break a bond. Bonds hold stuff together. To break bonds, like this cap is bonded to this pen. It's not going to fall off this pen unless I put some energy into it. Each bond has its own energy. There, endothermic, I got to put energy in to do that, right? Breaking bonds is endothermic. Fact, always. Got it? Bonds hold stuff together. How do you get stuff apart? You got to tear it apart, right? Okay, that's putting in energy. Now, where's this 402 on this handout? I didn't invent it. What kind of bond did you break? CH, correct? That means you're in the CH category. Which entry there matches this one? And this will be the last time it matches something on this table exactly. This will be the last time. Yet we'll be using this table every time. Okay. It's about categories, everybody. It's not about finding a match. There's a reason why we learned primary, secondary, tertiary, and well, apparently there's multiple reasons. It helps explain things like carbocation stability. Later on, we'll learn about, alcohol reactivity depends on the substitution, primary, secondary, tertiary. A lot of things depend on substitution. Substitution was just the beginning of describing things. Okay? Well, bond dissociation energy is the amount of energy it takes to pop a bond in half. Okay? It's called Lysis. This is homolysis. What does that mean? When I cut the bond, did the electrons go unevenly towards the two different atoms, or did it split exactly halfway? Split halfway evenly. What prefix is for even? Like evenly spread. We've used it before, homogeneous solution. What does the homo mean then? Evenly spread throughout the solution. What does homo mean here? Evenly split the bond. There's your homo. And lysis means split, right? Learn that. It's for biology and chemistry. Okay, now one we don't see on the table. And this one I want to go. You will not find that bond on the table. You're not in the CH category anymore. CH category was pink highlighter. CH, we're in a CI category. That's not a pink highlighter. That's a purple highlighter, of course. CI. Let me give you the heads up. Here are the categories named. I'll do it on the CH because it seems like there's the most categories there. And I'll take my time. This is not worth points. This is just you learning right now. First one's called methyl. So if you need to break an H off of a methyl, how much energy do you put in? 439 kilojoules per mole. This one is primary. I hope you agree. This one is secondary. That's the one I used in the first example. That's where I got the number. It's the same molecule. Isopropyl, really. I mean, it's propane, but you're taking the middle H off. The H is attached to an isopropyl group, right? Tertiary. What's the name for an H attached to an alkene? Hey, if you had to name that alkene as a group, you have a name for it. Nomenclature name. Chapter 5. 2-carbon group with a double bond in the 2 carbon. Vinyl. Ladies and gentlemen, if you have a choice of vinyl or any other kind of CH, which one's going to break first? Any other CH except for alkyne is the only one where it's harder to break that bond, right? You don't have a name for that group. I want to point out that these three are all called allele. I'm going to move this over just a hair. Allele. What's the distinction? Primary is the first one. Secondary is the next one. Tertiary is the next one. Which of the alleles is easiest to break? More energy means harder to break. Less energy means easier to break. If I have a choice of alleles, I'm picking the tertiary. If I have a choice of anything that I've labeled in blue so far, which of the ones that I labeled so far is breaking the most easily? Tertiary allelic. That's how I say it. Tertiary allelic. Primary is harder to break. This one's called phenyl. Are you surprised? No, that's a phenyl group attached to H. These are all called, whoops, it's a triple entry again. I shrunk this down and some of the bonds kind of disappeared because I shrunk it down too far. These are all called benzyl. Benzyl is phenyl plus an extra carbon. I hope you see that. You should be able to see that. Okay, and which one's primary? The first of those. No, that's phenyl. That's not even in the same league. Primary, secondary, tertiary. You're not going to be breaking any phenyl CHs. You're not going to be breaking any vinyl CHs. Those numbers are just too high. Alkyne, forget about it. Don't break those. Okay, so we're into the iodine category. Give me the category of that purple highlighted carbon. Don't just say secondary. You would have missed the whole point over here. Secondary is half the story. What's the other half of the story? When you're a carbon on a carbon that's an alkene, you are the carbon attached to an alkene carbon. What's your name? Allele. What's your number in this example? Primary, secondary, tertiary. Which one? Secondary. I need secondary allele. This one was secondary and an exact match. That's why I just used it. But this one's secondary allele. Where are your alleles? They're the carbon one away from an alkene. Primary, secondary, plus 169. Plus 169. Kilojoules per mole. No units? Oh. No units? You should get no credit, but I'm not that harsh. I just lose a half. You lose a half point with no units. All right, let's flip it. A lot of things are flipping here. Sorry. Okay, let's do this reaction here. Yeah. What do we want? We want to do and that's a dot. Get some weird stuff here. Well, I think you can tell me the answer to the question, what would that energy be from the table directly? That's a bond dissociation energy, isn't it? So I want the green arrow, but the black arrow's for this table. And getting the right number depends on the black arrow. So what kind of a bond are you breaking? Give me a category. Primary, secondary, tertiary. Tertiary CF. Tertiary CF, that's the second column here. And which of those is the tertiary one? Well, it's this one right here, isn't it? C with 3 CH3. And that's positive 416 to break it. That's not your answer. That is not your answer. You weren't asked about that reaction. The answer is negative 416. I can't say it enough times. I don't even know what happened there. Tertiary is the category, 416. 446. Where did 416 come from? Did I, 416 was wrong down here. Where did 416 come from? Oh, allylic. Tertiary is 446, right? Thank you for catching that. That would have been a nightmare studying that. I'm never going to get this stuff because that makes no sense. I'd be with you on that. So the answer is not 446. It is what? I think you know how to figure it out. Negative 446. Don't forget, kilojoules per mole. The tertiary's got to move. It's getting confusing. Okay, now we're over here. We're doing this thing. Breaking bonds is what, endo or exothermic? Yeah. And of course, the opposite is true too. Get some pink in there. Double pink. Making bonds. Breaking bond is. Sorry about that. Should have been plural. And then you don't have to memorize any equations. There's no equation, none. Just use breaking as endo and making as exo. And one more example just for fun. And let's do this one. I don't know. There we are. I did something like this one. No, let's go this way. Go the other one. There we go. And we need the chart. I think we have everything we need there. What you got for me? I want to make sure we have the answer there. I will await your answer. What you got? Are you making a bond or breaking? Sorry? Making a new bond. So the electrons got more stable. I hope you see that. Isn't that what exothermic means? The electrons get more stable? Yeah, well, if you're a radical, then you're not shared by two atoms, are you? Where would you rather be? An electron just near one atom or between two atoms? It answers itself. There's only one thing in the world I like, and it's protons, and you got me between two sets of protons, I'm happy. You got me only near one set of protons, I'm not happy. Radicals aren't happy. Ask Che Guevara, he wasn't happy. People were being mistreated. Anyway, that's a different kind of radical, way before your time. It's okay. Okay, exothermic, right? You got a number for me yet? -169? I agree. It's all categories. Yeah, we're in the CI category, tertiary allylic, correct? Or secondary allylic. My bad. And I'll use a new highlighter, yellow. Yellow. And that's up here, right there. You agree? Yeah. Okay. So that was like a pre-activity. Good video all by itself.